Section 2.5, example 12, finding the length of the missing side of a right triangle. Find the length of the missing side of the right triangle. So where do I start? We have the equation, the Pythagorean theorem. Yeah, Pythagorean theorem, which is a squared plus b squared is equal to c squared, where a and b, actually the only important one that we have to kind of throw somewhere is c. C is always going to be away from our 90-degree angle. So this one here is going to be C. The other two, it doesn't really matter which one's which. Here, they already labeled this as being A, so we could call this one B. From here, we're just going to plug it into the formula and see what we end up with. So A squared, we don't have any value for A, so it's just going to remain as A squared, plus B squared, that's going to be 4 squared, is equal to C squared, which is 12 squared. There's a lot of things that we could do here. Let's simplify first. A squared is not going to simplify at all, so we're just going to leave it as A squared. 4 squared is 16. That's equal to 12 squared. 12 squared is 144. We're going to subtract both sides by 16. A squared is equal to 130, 28. Yep. And from here, we take the square root of both sides. A is equal to, normally what we would do is a plus or minus, but we don't have negative values with distances. So it's just going to be a positive. And 128, let's do it the old school way. So 128, let's keep factoring until we find values that make sense. So this is an even number, so I know it's divisible by 2. 12 divided by 2 is 6. 8 divided by 2 is 4. And right off the back, we have a square root. So we could take the square root of 2 times 64, because I know the square root of 64 is equal to 8. So we could pull this out and say that we have two products of 8 there. 8 root 2. And that's our solution. 8 root 2, simplified form. If you have any questions, please feel free to ask. Otherwise, bye.